Good evening. Miscellaneous exercise sum number 26. Let me read the sum first. If TP, TQ, TR of a GP are X, Y, Z respectively, find the value of X raised to Q minus R into Y raised to R minus P into Z raised to P minus Q. I have begun with let capital A be the first term. You could have taken small a also as the first term, but you should not take small r as the common ratio because TR is given. So we take capital R as the common ratio. Now TP, TQ, TR are given to be XYZ. But what is TP? AR raised to P minus 1 and so on, right? So we get this. Now what is asked? Substitute the values. Therefore, X raised to Q minus R into Y raised to R minus P into Z raised to P minus Q equal to, substitute the values of X, Y, Z. So A capital R raised to P minus 1 raised to Q minus R, A capital R raised to Q minus 1 raised to R minus P into capital A R raised to R minus 1 raised to P minus Q. Simplify this further. So this is capital A raised to Q minus R into capital R, A raised to M raised to N, A raised to Mn, so P minus 1 into Q minus R into capital A raised to R minus P into capital R, Q minus 1 R minus P into capital A raised to Q minus R, capital R raised to R minus 1 into P minus Q. So what is difficult? Laws of indices. So A raised to, add indices, Q minus R plus R minus P plus Q minus R. This is what? Index of A. Now index of capital R. P minus 1 Q minus R, right? Plus Q minus 1 R minus P plus, this is in index only, R minus 1 P minus Q. What next? You have to use common sense. We have to prove that this is 1. So clearly it is A raised to 0, R raised to, open all the brackets. Okay, and sum of them or sum of all terms should be 0. Then only you will get 1 as the answer. So PQ minus PR minus Q plus R plus QR minus PQ minus R plus P plus PR minus RQ minus P plus Q. Just check this. If you want full marks, you have to write all the steps. So this is nothing but 1. Write down. Actually 27th we had done this type. So for homework, let me read the sum. Which two terms are inserted between 5 and 40 so that the resulting sequence is a GP? You have to begin with let G1, G2 be the required terms. So 5, G1, G2, 40 in GP. 5 is first term and 40 is fourth term and so on. Correct answer 10, 20. Sum number 28. If PQR are in GP and P raised to 1 upon X equal to Q raised to 1 upon Y equal to R raised to 1 upon Z, verify whether X, Y, Z are in AP or GP or neither. Now PQR are in GP. So second upon first equal to third upon second. So Q square equal to PR, number 1. Now we are given this. See, we should try to get relation between X, Y, Z. For that, we have to eliminate PQR. And therefore, I express both P and R in terms of Q. Q will be eliminated, right? Now, P raised to 1 upon X is Q raised to 1 upon Y, taking X power for these two. So, P raised to 1 upon X raised to X is P. Q raised to 1 upon Y raised to X. See, that is why I have written P equal to Q raised to X upon Y. Similarly, R equal to what? Q raised to Z upon 1. Now put these in 1. So Q square equal to Q raised to X upon Y into Q raised to Z upon Y. Add indices. So 2 equal to X plus Z upon Y. So 2Y equal to X plus Z. At this point, you can say that Y is arithmetic mean. So X, Y, Z are in AP. Or you may say that rearrange the terms to get Y minus X equal to Z minus Y. Difference between two consecutive terms is constant. So X, Y, Z are in arithmetic progression. 29th, if A, B, C are in GP and ax square plus 2bx plus c equal to 0 and px square plus 2qx plus r equal to 0 have common roots, then verify that pb square minus 2qba plus ra square equal to 0. Now ABC are in GP. So B upon A equal to C upon B. So what is B square? It is nothing but AC. Now put this in the equation ax square plus 2bx plus c equal to 0. Now B square is AC. So what is B? Root AC. So this becomes ax square plus 2 root AC x plus c equal to 0. Note that left hand side is perfect square of root A. Remember, x is not under radical sign. Root A into x plus root c bracket square equal to 0. So root ax plus root c equal to 0. So what is x? Minus root of c upon a. Since these two equations have common roots, I can say that x equal to minus root of c upon a satisfies this equation. Replace every x by minus root of c upon. So p square of this square of negative number is also positive. So p into c upon minus 2q root c upon root a plus r equal to 0. Multiply both the sides by a. So pc minus 2q. See, denominator is root a. So this is just root c into root a. Though I have multiplied by a, here denominator contains root a. So only root a. So root a root c is root ac. Plus ar equal to 0. Now b square is ac. So what is c? B square upon a. And what is root ac? It is nothing but b. So equation 1 becomes p into this c is to be replaced by b square upon a minus 2q. What is root AC? B plus AR as it is equal to 0. Multiply throughout by A to get PB square minus 2QBA plus RA square equal to 0. This is the required condition. Sum number 30. If PQRS are in GP, show that P square plus Q square plus R square into Q square plus R square plus A square into PQ plus QR plus RS bracket square. Let R be the common ratio. Why to take capital R? Because small r is already used. So P is first term. What is second term? Q. First term into common ratio. So Q is PR. What is small r? PR square. To get the next term, we have to multiply the previous by common ratio. What is S? PRQ. Now LHS simplify. Replace QRS by these. On simplification, you get LHS as what? From this P square can be taken common. From this P square, R square can be taken common. So ultimately LHS is P raised to 4 R square into square of this. Similarly, right hand side, you will notice that LHS is same as RHS. 31st, if PQRS are in GP, show that P raised to n plus Q raised to n, Q raised to n plus R raised to n, R raised to n plus S raised to n are also in GP. To show that three terms or three or more terms are in GP is to show that the ratio of two consecutive terms is constant. Now let R be the common ratio of GP. Why to take capital R? Because small r is already used. So Q is PR, small r is PR square, S is PRQ. Now in order to show that these are in GP, we have to show second by first equal to third by second. Now begin with this, substitute the values. You will notice that on simplification, what remains is R raised to n. Because from numerator, P raised to n, R raised to n can be taken common. From denominator, P raised to n. This gets cancelled, P raised to n gets cancelled. What remains is R raised to n. Now R raised to n plus S raised to n upon Q raised to n plus R raised to n. Same logic. You will notice that here also you get R raised to n. Right hand sides are equal. So left hand sides must be the same. This means that these three terms are in geometric progression. Actually, this part is there in the textbook, but we will discuss this once we discuss the topic permutations and combinations, because in that we have to discuss this. This is called as factorial notation. So exponential series, I think logarithmic series is also given, and finally sin x and cos x. This is an infinite series. Sin x is x minus x cube upon, how to read this, 3 factorial and so on. Okay, and therefore at present we won't be able to do sum number 32 and sum number 33 given in the exercise. 32nd reads, find the coefficient of x raised to 6 in the expansion, and in 33rd we are asked to find sum of infinite terms. I think 33rd is based on arithmetical geometric series, so we will solve 33rd. But before that, let me tell you about arithmetical geometric sequence. A sequence in which each term is the product of the corresponding terms of an AP and a GP is called an arithmetico-geometric progression. You have to take the literal meaning, arithmetico-geometric. So a sequence in which each term is the product of the corresponding terms of an AP and a GP will be called as an what? Arithmetico-geometric progression. Consider the arithmetic sequence whose first term is A and common difference is D. So what is that? It is A plus D, A plus 2D, and so on. What is the nth term? A plus n minus 1 into D, and so on. There are many more terms. Also, the terms of the geometric sequence whose first term is 1 and common ratio is R are what? 1, R square, up to what? R raised to n minus 1, and so on. Now you may ask me, how can you take and why should we take first term as 1 only? See, if the first term is say 2, second term is 4, third term is 8, I can always take 2 common so that the resulting terms will be still in geometric progression. So we can have terms 1 to 4. So what is the first term for 1 to 4? It is 1 only. This suggests that if for GP first term is not 1, you have to take that number common. Okay. Now multiplying the corresponding terms of the above two sequences, we get the sequence whose terms are. Can you tell me those terms? A into 1 is A, comma, A plus D into R, comma, A plus 2D into what? A plus 2D into R square. I will not write that, but can you tell me the next term? Yes, it is A plus 3D into R cube, and so on. And what will be the nth term? It is A plus n minus 1 into D, bracket complete. You have to be very careful. After completing the bracket, You have to say r raised to n minus 1 and so on. Okay. Now this sequence is called the arithmetico-geometric sequence, and this is nothing but the nth term of this particular sequence, AGP. Now small d is the common difference and small r is the common ratio of this sequence. Now the series corresponding to this arithmetico-geometric sequence is the arithmetico-geometric series. Now let us try to obtain sum of n terms of AGP, and if the common ratio, its modulus value, is less than 1, we will be interested in finding the sum to infinity of this particular arithmetico-geometric series. Let Sn be Rm is to find sum of the n terms of arithmetico-geometric progression. Let Sn be the sum a plus dr plus a plus 2dr square up to what? This is nth term, a plus n minus 1 into d r raised to n minus 1. Now open the bracket. So a plus ar plus dr plus ar square plus 2dr square and so on. Now multiply by r, multiply each term of 1 by r. So what is rsn? It is ar plus ar square plus dr square plus ar cube up to what? Up to n minus 1 dr raised to n. Subtracting 2 from 1. So Sn minus rsn. See what remains is a, because ar gets cancelled, ar square gets cancelled and so on. Okay. So a plus dr. Actually from 2dr square is subtracted. So dr square dr cube up to what? Dr raised to n minus 1 minus ar raised to n minus this. Okay. Remaining terms get cancelled. Now take Sn common from these two terms. So Sn into 1 minus r equal to, now a plus dr square up to this. These terms, which one? Dr, then dr square up to dr raised to n minus 1. These are in all how many terms? Not n, but n minus 1 terms. These are in geometric progression. First term is dr. Okay. And what is common ratio? Dr square upon dr, that is r. Yes. Now from these two terms, what is taken common? R raised to n, to get this. Next step, a plus dr 1 minus r raised to n minus 1 upon 1 minus r minus this. Now common ratio is not equal to 1. So we divide throughout by 1 minus r to get Sn equal to a upon 1 minus r plus dr into 1 minus r raised to n minus 1 upon square of 1 minus r minus this upon 1 minus r. See, if you have understood the proof, result can be remembered. I won't say easily, but if you write this 10-15 times, then you will definitely remember this result. Okay. Now sum to infinity. You have to use common sense. If modulus of common ratio is less than 1, then see the cursor. R raised to n minus 1 will approach 0. As n approaches infinity, r raised to n minus 1 approaches what? 0. So this is dr. See, a upon 1 minus r as it is, because small r raised to n is not there. Okay, r is very small. Fine. It won't change a upon 1 minus r. But here, as n approaches infinity, small number raised to n minus 1 approaches 0. 1 minus 0 equal to 1. So dr upon 1 minus r bracket square. See this. Minus, note that r raised to n approaches 0 as n approaches infinity. If you want, I'll explain this part once again. Now 0 into this is nothing but 0. That is why you cannot see this. I hope you will be able to remember this formula, because first part is the same. For simple geometric progression, sum to infinity is given by a upon 1 minus r only. There is one more term in case of AGP. Okay. So you have to remember these two formulae. If sum to infinity is asked and if modulus of common ratio is less than 1, go for this formula. Otherwise, use this one. Exercise 2.5 will be doing first sum of first question. Find Sn of the following arithmetico-geometric sequence. Okay. So the first one, given sequence is what is that? It is 2 4x 6x square 8x cube 10x raised to 4 and so on. Okay. Can I say this is arithmetico-geometric sequence? That is, it is better if we write 2 into 1 plus 4 into x plus 6 into x square plus 8 into x cube and so on. Write down. This is AGP with what is small a? These are standard notations. Small a is 2. What is common difference? 6 minus 4, that is 4 minus 2 is 2. Can you tell me what is the common ratio? Common ratio is x. Therefore, Sn equal to, do you remember the formula? See, it is not at all, I won't say it is not at all difficult, but if you know the proof, you can easily remember the formula. A upon 1 minus r plus dr into 1 minus r raised to n minus 1 upon what? 1 minus r bracket square. Okay. Minus, see, this part can be remembered easily. This is nth term of AP into r raised to n upon 1 minus r. Now, substitute the values and simplify. So, let's check. 2 upon what? 1 minus x, is it? Plus 2x, use brackets, 1 minus x raised to n minus 1 upon square of 1 minus x minus 2 plus, is it? N minus 1 into 2 again, x raised to n upon 1 minus x. See, you have to simplify this. So, Sn 2 upon 1 minus x. Can you simplify the second part? 2x. I don't think this can be simplified further. 1 minus x square and minus. If you open the bracket, can we do this orally? 2 plus 2n minus 2. Okay, 2 gets cancelled. So can I say this is minus 2n x raised to n upon 1 minus x. Now, can we say that this is the final answer? Or should we consider first and third term and LCM as 1 minus x? So it will be numerator. I'm omitting one step. See what is numerator? 2 minus 2n into x raised to n. So if I take 2 common, then it is 1 minus nx raised to n. Please check this. Upon 1 minus x plus 2x 1 minus x raised to n minus 1 upon 1 minus x bracket square. Let's check this. These are the answers for homework sums. Second question, find the sum to infinity of the following arithmetic geometric sequence. We'll be doing first part. What is that? 1, 2 by 4, 3 by 16, 4 by 64. So what we require is, what is small a? First term of an AP, 1. Common difference, 1, 2, 3, 4 are in AP. So common difference 1. What is common ratio? 1 by 4. What is modulus of common ratio? 1 by 4, less than 1. So sum to infinity exists. Tell me what is the answer. So I write given AGP as 1 into 1, 2 into 1 by 4, 3 into square of 1 by 4, 4 into cube of 1 by 4. See, first terms are terms of AP, second terms are terms of GP. So what is small a? First term of an AP, 1. What is common difference of an AP? 1. Common ratio of GP, 1 by 4. What is modulus of common ratio? 1 by 4, less than 1. So sum to infinity exists. Mention the formula. S is A upon 1 minus R plus dr upon square of 1 minus R. Substitute the values. Tell me the answer. Okay. Somebody has written 4 by 3 plus 4 by 9. So it will be 16 upon 9. Check this. 16 upon 9. Remaining two sums for homework. Now miscellaneous exercise sum number 33. Find the sum of infinite terms of 1 plus 4 by 5 plus 7 by 25 plus 10 by 125 plus 13 by 625. Can I write the terms in this series as 1 into 1? This is not decimal point. Plus 4 into 1 by 5 plus 7 into square of 1 by 5 plus 10 into cube of 1 by 5 plus 13 into fourth power of 1 by 5. Clearly this is AGP, arithmetical geometric progression. With usual notation, first term of an AP 1, common difference of an AP is 4 minus 1, that is 3, common ratio 1 by 5. As modulus of common ratio is less than 1, sum to infinity exists. What is S? A upon 1 minus R plus dr upon square of 1 minus R. Substitute the values. Okay. Two students have written the same answer, but one student is getting different one. I hope this is correct. 5 by 4 plus 15 by 16. So this is 35 by 16. So that's it for today, and we have finished this topic, an important one.